Welcome back to another HVAC-Engineering-Techie training video. Remember, these training videos are technical in nature and intended to help your career. Remember, this is the channel that talks all things HVAC, engineering, design, construction, equipment, systems, test and balance, controls, efficiency, and performance. Today is another one on our commissioning series for continuous performance tracking systems. This is something that is not discussed a lot in the commissioning world, but it should be. This is a requirement in the standard 110, and basically it is to make sure that an owner has a system to track performance so it doesn't degenerate over time. So before we start, please become a subscribing member. I'd really appreciate it. Hit the subscribe button down below. Give me a thumbs up. These are painless for you, cost you absolutely nothing. But it's important to me because Google uses that data to value the channel, which actually keeps me on the air. So I really appreciate it. Let's get started on the video. Thanks. So today we're going to talk about a continuous performance tracking system, what those are, how you create them, how you use them, and what benefit they actually give to the owner. A performance tracking system is a system that allows the building owner and operators to continuously track building performance over time. This system can be a simple manual tracking system or an automated data analytics system. So it can be quite complicated or it can be really simple. The tracking system shall utilize periodic energy and water bills or use data as the main basis for performance. Tongue twister there. The main purpose of the tracking system is to prevent degradation of system performance and to continuously improve performance over time. Now, this does work. It works very well that if you actually look at what you do and say, well, that's not quite perfect, what can we change to actually make it better? It can actually improve. I had a customer one time that hired me, this is years and years ago, it's a big hospital, and they said, we need to improve our energy. We'd like to hire you to do that. I said, oh, great, I can do that. It's good. Well, you don't understand. We just want you to come in once a year and look at our facility and talk to our operators, and then we'll make a change. We'll see what happens. And we'd like to save 10% on our energy. I thought, well, that might be kind of hard. So we did that. And we actually did it 5 years in a row. We come in, we look at what they got, propose something. They've spent the money to do it. And we actually reduce, over a 5-year period, reduce their consumption by 50%. Now, that's really impressive. But I got to tell you, they were really bad to start with. So it wasn't too hard to do, but it does work. If you measure it and see what you're doing and make a change and improve it, you will improve a facility's operation. Tracking system activities are performed by the building operators or energy manager, normally on a monthly basis. So the monthly performance evaluation is published to the owner, operators, and occupants in an effort to keep all parties who can affect the building performance informed on performance progress. Now, why would they care? Well, If you have a lease building and you have leasees in the building, and as the energy rises, guess what? Their bill goes up. So they have an interest, the occupants have an interest in keeping the bills low so they don't have to pay so much. And of course, the owner wants to keep them low so his profits are higher. And the operator should want to keep them low just to show the owner they're doing a good job and possibly get a raise. So that's why it's important to everybody. And we publish it to them so they'll see whether we're doing good or bad. It is assumed that the owner will keep the operators and occupants motivated to help improve performance to keep operating costs low. So that's the perfect world we're looking for. So the basic process is you collect the data bills, your utility bills for electric, gas, and water, or anything else, like if you have district steam or district hot water or district chill water, you have invoices for those. Anything that's costing you money to operate your building in a utility sense for energy or for performance, you collect those monthly and then you analyze them in some kind of form. Either you have an automated system or you have a spreadsheet set up for it, and then you actually publish that to occupants in some way they can understand. And normally we prefer to do that with graphs because people can understand a graph. These numbers are kind of hard to figure out what's going on here unless you're the guy doing it. And we'll explain all this later on. But this is the general process, and you do that every month. you get this data, you analyze it, and say, well, okay, this is where we were, and you compare it to past data. So you got one of these spreadsheets set up for last year, and you said, okay, we're doing better than we are last year. So we'll explain how to do all that, and then you publish the data, and then if you see improvements, you make improvements. You do the whole thing over again. You do it every month, and you tell where you're going. And these data, of course, shows current and month to date, that kind of thing. So manual tracking system, which are by far the cheapest and easiest because they just cost you labor to do. They don't really cost anything. Create a spreadsheet that can track monthly energy use that allows normalization for billing days, occupancy, and degree days, and for weather. The reason we normalize the data is if you have a building that operates a year with 1,000 people, and then a whole bunch of tenants move out, and you have 500 people, the energy that year is going to be much different than the year before. So we want to normalize the data so we're not penalizing ourselves for something that we have no control over. So that's what normalization is for. Now, normalization for days just means that, unfortunately, utilities don't always bill the same amount of days per month. So say in 2024, in January, they may have billed for 30 days. And the next year, they may be 28 days in their billing cycle. So that's a problem. We need the days to be consistent between years when we're analyzing data. So this is all it does. It takes everybody to a 31-day situation, a 30-day situation, and it just keeps them all equal. So that's normalizing for days. And then for weather, you can really get sophisticated and do all kinds of analytic systems, but for simple, we're just using degree days. So if one year it's really, really cold, the next year is hot, the degree day will normalize it somewhat. Not a great deal, but somewhat. Now, some people say, well, that can't make that, does that help? I mean, the degree day doesn't make a big difference. Well, it turns out that the environment, the ambient air temperature and conditions only affect a small percentage of the total energy used by the building. Most of it's internal load. So normally a building has about 20-25% external load. Depends. If it has a building has a lot of people, maybe 30%, 35%. But that's it. The rest is all internal load, which is not affected by the weather. So we still want to normalize that data, and that's why we do that. The spreadsheet shall have at least 12 months of past data to compare for present usage. The spreadsheet shall have automatic graphs and energy and water usage that can be used for publication. Establish a methodology of collecting usage data and cost. Normally task accounts payable, accounting to forward utility bills to the energy manager or lead operator, depending on who you have doing this. Publish to obtain approval to download billing directly data from the utility. You can, if the owner approves it, you can get special set up with a utility to just send those bills to you also. So you can have those. If the owner says, this is the guy we're having doing energy management, they can do that. If the facility does not have utility meters and is not billed for usage, obtain usage readings directly from sub-meters. Now back here where we're going to it normally has accounts payable to forward utility bills. That actually is pretty specific. You don't want accounting to send you a readout of their computer system, their accounting system that has the cost by month, right? Or maybe it might have the usage, but probably not. But you need the details on the bill. So they need to actually send you a copy of the bill because there's a bunch of things you need to see that they don't understand. So basically, don't have them just send you a list of costs. You need something more than that. If the facility doesn't have utility meters and you're not billed for utility, obtain readings from sub-meters. And you say, well, how could that ever be? Well, I've done a lot of work for utilities, and most of them don't meter their buildings. They call it line loss. On electrical, if they don't have electrical meter, they just call it line loss. Or they do have electric meters, they just don't do anything with the data. They don't. Some of them actually read it, but they don't do anything with it. Because they're not paying for it, right? It's their power. They're selling it to you. And the same with gas. I've seen many, many buildings without gas meters. So it depends on the circumstances. Just because you and I have meters doesn't mean everybody has meters. So then you create a performance measurement plan. The plan shall include who is responsible for what activity and the time schedule for each activity. So you have to have a plan So this is done consistently. This is really important. Consistently is important. You know, if you skip a couple of months because you're busy or whatever, that can't happen. It needs to be a consistent process. And so on manual systems, it just has to become a normal thing you do all the time. The basic operating system is as follows. Collect and document current utility data usage, compare the past usage, collect and document independent variables, compare the past variables and adjust original baselines as required, compare the baselines. Now, baselines are something maybe if you're tracking against Energy Star portfolio manager and you're tracking within that, or you're using these check sheets, these spreadsheets to track whatever you're doing. You compare to how do we look? How does this building look amongst other buildings, other peer buildings? Report results, make changes for operation improvement, verify improvement of changes, return to the first step above. So this is just a process. And you do it all the time. And this actually works really, really well, and it's really easy to do. You know, this may sound complex, but it's really simple to do. And, you know, it's not been done everywhere. Not everybody does it, so it may be a little new to some people, but it's really an easy process. Here it is. Basically, there's your measurement plan. You collect the data. You analyze the data. You normalize the data. You look at baselines, how you're comparing it. You compare results to past year. You publish those results. And then you make changes and you do it again. It just keeps going in a circle. I would say the most important part is basically the analysis of the data and your make changes. What changes this analysis to make these changes is what's most important. You're analyzing the data, where are we at, and then you have to work on what you can change, and you make a change. You know, sometimes you make a change and you go the other way. You know, wait, that didn't work. And so when you measure that, you gotta go back and rethink that. If the system is new, the commissioner shall perform the first cycle of the performance tracking system. If it is an existing system, the commissioner shall review the first cycle of verification performed by the owner to make sure everything's going okay. The commissioner shall compare present performance results to past results and shall determine if performance is improving or degrading. If performance is degrading, the commissioner shall initiate an RXC, a retro-commissioning process, to find the root cause of the performance degradation and make changes to improve the performance during the next cycle. Now, the key to that and to retro-commissioning is basically the root cause, to finding the root cause. Most people don't do that. They end up finding a symptom, and they'll make a change for a symptom, which makes things worse. It doesn't make things better. So you have to get adept at finding root causes. It takes a little bit of effort to do that. But once you've done it, you can actually make a change that will make a change. If the system is new, the commissioned professional shall train the owner's staff on the correct operation of the system for continued operation of the performance verification system. Using the output data and graphs from the system, the owner and commissioners shall publish the results to the managers, operators, and occupants for each cycle of the system. If changes are made to improve performance that modify system operating parameters, the commissioner shall modify the facility operating guide to reflect those changes. In other words, if you make a change that really helps and you don't tell anybody, you don't write it down, and they change operators, he comes in, he doesn't know, he may take it back to the way the system was operating before, which could degrade your performance. Okay, here's a system of a manual system. Now these sheets I've actually created. I created them for ASHRAE some time ago for a performance measurement protocols, and they do have a document they sell which has these embedded in a disk in the manual. Unfortunately, I don't know if anybody ever used these. I've used them, but I don't know that they did. And the problem is with spreadsheets, it's okay when you create it, you know all the little intricacies of it, but trying to figure this out when you don't create it is somewhat complex, and I do understand that. So anyway, this sheet is designed for electrical energy. It's created off the bills. This is the facility information up here. Here's the electrical meter data and what the rates are and all that stuff. These are the individual months. This is the billing usage data. And these can become quite complex for electrical because they can have on-peak, off-peak, shoulder peak, 3 or 4 different measurement areas where they're measuring. So this has a few things to fill out. Now, on this particular spreadsheet, the yellow is the cells you actually put data in. All the rest of the data is automatic, so you don't put it in. So then this is the bill cost data, and you input the cost data. It doesn't calculate that automatically, except for a few of the use data, because there's a whole bunch of tariffs placed upon power. The federal government does it, the state governments do it, municipalities do it, so there can be a whole slew of separate fees and taxes, overrides, all kinds of things on utility bills. So when you get a utility bill, I was hopeful that you would not have any more. If you have more, you're going to have to change a spreadsheet, and these spreadsheets are not locked. Well, they are locked up, but the password is given to you written on the document, so you can always open it up. And the reason is trying to get you not to overwrite these formulas. Otherwise, you got to figure them out again. So it's not hard, but it may take some time. So this here is the occupied square foot data. So that is the data you put in from the previous year to this year. This is how much square foot is actually occupied. So if you have a lease building and only 50% of it's occupied, you want to change that so you can only see, you're only comparing to occupied space. And then, of course, this is the degree day. And degree days you get by downloading it from the internet, from the local weather service or from National Weather Service. And they do that every month, so you can keep track of what the degree days are. And then this is the prior year energy, and it's exactly the same thing. Usage data, billing cost data, occupied square foot, and degree day data. And so this gets fairly easy once you got it set up. So first, when you first start, you have to go back and create all the last year's bills. And you get all the last year's data. Now you can continue to do your first data. So the occupied square foot, degree day data from the past is there. This is the output of that system. It's all automatic. And it basically gives you a sheet you can print out and put in a report. It has a current month efficiency. And what happens is if you get better and better, it starts going, the speedometer goes toward the green. If you get worse and worse and worse, it goes toward the red. And then it gives you a percentile number of how efficient you were compared to last month. And then this is the EUI, which is the Energy Use Intensity Index. And this is a thing that ASHRAE uses a lot to kind of compare facilities to facilities. It gives you your cost per square foot and that sort of thing. And then it has the comparative annual use trend. This tells you if you're getting better or you're not getting better, and it shows you what this year looks like and what last year looks like and where you're at. This one shows you the variance use, the trend variance. So it says your trend is actually down, so you're actually getting better, which is really good. This is the comparative monthly use, shows you what you did each month. And this is the electrical variance by month. So it tells me in January you spent a little more, in February you spent a little less. These 2 months were really good. That one was really, really good. So it shows you where you're doing good and where you're not. So it actually makes it easy to tell where you're at without having to worry about the numbers. And then this is for cost, same thing. So it has the total annual cost, electrical cost data trend, total by month, and the electrical cost variance by month. So it helps. And then we do the same thing for gas. The gas sheet is exactly the same. Gas is slightly different sometimes because it may not be in actual cubic feet or therms. It may actually be in units. And up here is a definition of how many therms are in a unit. So now you can put the usage in. And the usage is actually, this is the dates up here. The usage dates are there. And these are, of course, the cost data. And this is the occupied square foot again, just like electrical. And this is the degree day, just like electrical, because gas is also affected by weather. And then, of course, it's the prior year, which is exactly the same thing. And then it puts out another chart, which is for gas. And it has a speedometer, which tells you how efficient you are. Then it has GUI, which is a gas intensity, use intensity. And this is a comparative annual use trend. And this is the gas use variance trend, shows you're doing better. This is the monthly data. And this is the month variance data. So these are helpful graphs that will help you be able to publish the data to your occupants and operators and owner. And the costs the same. Utility water is the same. It has facility information. Again, we have some water meters may not read gallons, they may read units. So you have to put in here what one unit is if it has units. If it has gallons, it's really easy, just use gallons. Here's the bill of usage data. This is the building cost data, occupant data. Okay, now water is slightly different. How you calculate water for a building if you're designing a new building is based by how many people by gender are in the building. Because male and female actually use the restroom differently, and maybe more use on one or the other. So they've recorded all this stuff and they've got a design data down. So what you need to do is track how many people you have in the building, and that can actually be difficult. So it's easy if you have a card access system. You can do it automatically. You just get that report from your operation, or maybe you got it directly, and you just input how many people have in the building. The only difference is it's full-time people. So it's people that are there for a full day, 8 hours. Or if you have a lot of part-time people, then it takes those, adds them together, and divides by 8, then that has what you have. So this keeps it so you can compare to last year to how your water usage is. Now, one of the main this has more than 1 meter. This has the actual water meter. It also has a landscape meter, because in water use, landscape is a significant factor. Not so much for total use, maybe. Depends on the type of building and how much landscaping it has. But for leakage, landscapes are notorious for wasting water. So you have to kind of watch the landscape directly. Now, water is not a big deal for cost in most places. It's getting to be more expensive, but what it's mainly for is we don't have a lot of potable water. It's going to get more and more expensive, so water is going to become more and more important. And of course, prior years, the same thing. And it comes out with a chart just the same. It comes out with a speedometer, shows you what you're doing better and your efficiency. It comes out with a WI, which is water use intensity. And then it has comparative results between years. And it has water use variance trend. And unfortunately for water, you might see it bounce around a lot, mainly due to landscape issues. And then comparative monthly use. And then, of course, the variance difference. So it's the same thing. It's very helpful. And then, of course, we have cost as the same thing. So basically, these graphs are very easy to show people. Now, I might make a mention here, the data that's using these, just made up data. I didn't actually use a facility for this. I just had my water bills and I used those, but the data is all made up. So basically, I used it to test the graphs. So don't get wound around on why these look the way they do this. It's just data put in there to make sure the graphs actually work. Now, that seems, well, that's way too much work. Well, it is some work, but remember, the benefit can be great. So we're talking about benefits in the thousands and thousands of dollars, so it could be important. You can also automate this. There are many, many different ways to automate it, and there's companies out there that sell you software that will gather the utility data, analyze the data, and do it all automatically so you don't have to be involved in it. It'll do cost avoidance calculations, tell you what to change. A lot of them actually have software that looks at the utility bill itself and see if you're on the right rate, or changing rate a better idea, or there's any way you could offset peak periods and things like that don't involve any real things in the field. They should involve manipulation of the data in different cost avoidance calculations, and has data analytics, big computer system, so it's got lots of capacity for data analytics. Benchmarking, it can do automatic benchmarking to systems like Energy Star. Here's 4 of them that I found out there. Now, there are data analytics software, which are much larger systems, actually watching everything happen in your building and trying to help you change everything in the building. This is not what I'm talking about. These sites here are basically for trying to automate the cost tracking system of your utility cost. There's Energy Cap, Sky Foundry, SiteLogic, Atris, and there's probably many, many more. And there's lots of providers. Now, these are somewhat expensive because they have upfront costs to come in and look at your system and connect their system into it. And then there's a subscription cost of ongoing costs of these systems. So you'll have to evaluate those costs. I unfortunately don't have the cost of those systems, but they are available if you want to automate this. And then, of course, if you have a full data system in there, a full fault detection system, they can include this as part of their package. Is probably a more simple thing to do than to just try to do this by itself. So the deal is if you don't track use, you can never improve it. You can never improve it. And one of the biggest problems we have in this country, or all countries around the world, is degradation of performance. When we first build a building and we first commission and test it, that's probably as good as it's ever going to get. And after that, if the operators don't fully understand how to keep that thing running smoothly, it will degrade. And some of them degrade very, very quickly. I mean, I'm talking about 10 to 30% performance in 3 or 4 months, or at least 2 or 3 years. Because over years, what happens is system parameters change and they don't react to it. It will get worse and worse and worse. And of course, entropy happens. Things go to heck by themselves. So basically, you have to have a system like this to be able to get better and better and better instead of worse and worse and worse. So that's it. That's what a tracking system is. Hope you understood that. By the way, I am trying to figure out how to make these spreadsheets available to you. I'm figuring out how to put them on our website, and as soon as I get that figured out, I'll blast that out to the world, and you can have these spreadsheets. They're somewhat laborious to make yourself. You might as well, get my experience of spending days and days and days at making these spreadsheets. Alrighty, hope you enjoyed it. I appreciate you being a viewer of my videos, and I hope you have a great day, and I'll catch you on the next one. Thank you.